Part A says write down the inequality shown on this number line. So we can see we're going from -1 and then we're going all the way up. And now since this number line is referring to x, we can say that x is going to be greater than -1. Now something we need to consider, is it greater than like this, or is it greater than equal to? And in this case it's going to be greater than like this. We got to look up at this circle here. So if the circle is not filled in like this, we know that it's either greater than or less than, but it's not greater than or equal to or less than or equal to. So that's why in this case, greater than -1, however not equal to -1, because this circle on -1 is not filled in. And for that we get our 1 mark. Now for part B, we need to, on the number line, show the inequality y is greater than or equal to -3 and less than 4. So let's find -3 here and 4 up here. So it's going to be greater than or equal to -3. So we need to do our circle here, but we need to fill it in, because that essentially says that it could also be equal to -3. You can see that it's less than -4, not less than or equal to, because we don't have an extra line here. So I'm going to do my circle, but I'm not going to fill it in. And then our last step is to join it all up. So from less than -4 to greater than or equal to -3. And if we do that, we get 2 marks. Find the highest common factor of 60 and 84. So the first thing we're going to do is make a factor tree for 60 and 84. So what I mean by that is I'm going to start with 60 and we're going to branch off and look at some factors. So what two numbers multiply together to get 60? Well, we can get 2 and 30 would work. And as soon as we reach a prime number, we know that branch has stopped. So here we can see 2 is a prime number. So this branch has stopped and I'm going to put a circle around it. But because 30 isn't a prime number, this branch is going to carry on. Okay, so factors of 30. Okay, we could have 2 again and 15. Cool, so this branch has stopped because we got a prime number. But 15 we can carry on. So we can have 3 and 5 there, because 3 multiplied by 5 gives us 15. And now both of these are prime numbers, so we'll circle them. And we see we've got no branches to carry on, so we're all done. Now let's do the same thing for 84 over here. I can split that off into 2 and 42. So we're going to circle the 2 here. And 42, okay, well we can split that into 2 and 21. And lastly we'll get 3 and 7, which are both prime. So we're done. So what this tree has told us is that 60 is made up by multiplying 3, 5, 2 and 2. And the same way for 84, it's made up of 7, 3, 2 and 2. So now to get the highest common factor, we're going to work out what is common in each prime factorization. So you see we've got a 2 here, and if I found it in 60, I need to look, is it in 84? Yes, so I'll cross that off. So for our highest common factor of 60 and 84, we're going to have a 2 in there. Now we see, oh, we've got another 2 here that's common to both of them, so we're going to multiply by 2 again. And I can see, well, I've got 3 here and 3 here, so we can multiply by 3. However, I can't do anything with this 5 because that's only in this prime factorization, not over here. And there's only 7 here, not up here. So now we're done. So we've got 2 multiplied by 2 multiplied by 3, which equals 12, which is the final answer. So we get our first mark up here for our factor trees, and our second mark for the correct answer of 12. Now part B wants the lowest common multiple of 24 and 40. So again, for this question, we want to create our factor trees. So starting with 24. We can split that off into 2 multiplied by 12 and 6 multiplied by 2 and 3 multiplied by 2. Now one thing I just want to point out is you can split it up however you want. We can split it here as 2 and 20 because 2 multiplied by 20 is 40. However, you might also be thinking we could split up as 4 and 10, and that's absolutely fine. We'll end up at the same point however you split it up, so just split it up however's easiest for you. So now in this case we're going to have 2 and 2 and 2 and 5. So now we need to work out the highest common factor first in the same way we did before. So I've written out our prime factorizations. So the highest common factor of 40 and 24, we're going to look for our pairs. So I've got 2 here and here. So we've got a 2, 2 here, 2 here, and 2 here, 2 here. So it's going to be multiplied by 2, multiplied by 2. And that's it, because we haven't got any more pairs out of these numbers, meaning our highest common factor is 8. Now the lowest common multiple of 40 and 24 equals our highest common factor, which is 8, multiplied by the numbers we had left. So multiplied by 3 and multiplied by 5. And doing that we get 120. So again, our first mark comes from the factor trees up here, and the second mark for the final answer of 120. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. So we've got the time of day on this axis and the distance travelled in kilometres on this axis. And in part A, we need to work out Sam's speed in kilometres per hour for the first 15 minutes of his journey. Okay, so this is the first 15 minutes of his journey because we're going from 0 up until halfway between 10 past and 20 past. So essentially, we need to work out the speed represented by this line here. Now what we have here is a distance time graph because we're plotting the distance and the time. Now when we've got a distance time graph, we need to find the gradient of the line to work out the speed. So now the gradient of a line is worked out by the change in y divided by the change in x. So for the change in y, we're going from 0 kilometres up to 20 kilometres. So it's going to be 20 minus 0 kilometres. Divided by, okay, change of x, we're going from 10 o'clock to 10:15. So the change there is 15 minutes. So that's going to equal 20 over 15. However, we've got kilometres and minutes. So units here is kilometre per minute rather than kilometres an hour. We want kilometres per hour. So to do that, we're going to multiply by 60. So that gives us 20 over 15. Multiply by 60, which gives us 80 kilometres an hour, which is the final answer. So we get 1 mark here for our method, and 1 mark here for the correct answer of 80 kilometres per hour. At 10:15, Sam stops for 10 minutes, and then drives for 20 minutes at speed of 75 kilometres per hour. So on the grid, we need to complete the travel graph of Sam's journey. Okay, so we know that for the first 15 minutes, Sam's travelling. And then at 10:15 here, Sam's stopping for 10 minutes. Well, what does it mean to be stopped? Well, that means to be going 0 speed. Well, we're looking at a distance time graph, so speed is represented by the gradient of the line. So essentially, to stop means that the gradient needs to be 0. And for the gradient to be 0, that's just a horizontal straight line like this. So we need to draw that on for 10 minutes. So going from 10:15, 10 minutes from there is going to be to 10:25. So I'm going to draw on a straight line to there. Now for the next 20 minutes, we want to be driving at a speed of 75 kilometers per hour. Distance equals speed multiplied by time. However, for this to work, we need everything to be consistent, so we need to either be in hours and hours or minutes and minutes. However, we're not consistent at the minute. We're talking about travelling for 20 minutes at a speed of 75 kilometers per hour. So what you need to do is convert 20 minutes into hours, which is 20 divided by 60. I'll simplify that down, 1 over 3 hours. So now we can use this. I'm going to have the distance is speed, which we've got as 75 kilometers per hour, multiplied by time, which is a third of an hour. And this gives us a distance of 25 kilometers. So we're now going to plot this onto the graph. So this is for 20 minutes. So we're going from 10:25 to 10:45. And we know between here and here, we're traveling 25 kilometers. So starting at 20, we're going to do 20 plus 25, giving us 45. So our line is going to go like this, up to 45 here. We get 1 mark here for this straight line portion here. Another mark for working out the distance of 25 kilometers. And a third mark for this portion of the graph here. Complete the table of values for y equals x squared minus 2x plus 2. So the way we do this is we take our x value, we sub it into the right hand side of the equation, so replacing x with the value in the table. And then whatever we get for y, we put in this part of the table. We'll take a look at this box for an example. We sub in x as minus 2, and if we work that out, we get the value of y to equal 10. So 10's put in the table here. So we have to do that for our missing spaces in the table. So here we're going to get y equals minus 1 squared minus 2 minus 1 plus 2, giving us 5. Here we're going to get y equals 1 squared minus 2, 1 plus 2, giving us 1. So here we got y equals 2 squared minus 2, 2 plus 2, giving a value of 2. And last but not least, y equals 4 squared minus 2, 4 plus 2, giving a value of 10. And if you get all of those values correct, you get 2 marks. Part B says, on the grid, draw the graph of y equals x squared minus 2x plus 2 for values for x from minus 2 to 4. Okay, so that follows on really nicely from the first part. In our table from the first part, we were completing it for the same quadratic here, and we were going between x's minus 2 and 4. So we know the corresponding y value for each x value, so we can use these as pairs of points and plot them on the grid below. So when x is minus 2, y is 10. The next one, x is minus 1, y is 5. So going along minus 1 here, all the way up to 5. X is 0, y is 2. Well, x is 1, y is 1. It's going to be 1 along here and up to 1 here. and x is 2, y is 2. So up here, x is 3, y is 5, and x is 4, y is 10. So you see we've got a basis of a nice quadratic shape here. And lastly, we've got to try our best to join it up. And if we do that, we get 2 marks. And on the final part says use your graph to find estimates to the solutions of the equation x squared minus 2x plus 2 equals 4. Okay, so from this, we can split that up to say, okay, we've got y equals x squared minus 2x plus 2, and y equals 4. So our solutions, when we equate these, essentially, so saying x squared minus 2x plus 2 equals 4. So now we've got the graph of this plotted, so now I'm going to plot this. So plotting y equals 4, on the y-axis, let's look for 4, and that's going to be a straight line across here. Now we need to look at the points of intersection, so here and here, and work out the x values. So for this point of intersection here, we're going to go down and see the value on the x-axis, and same for this point of intersection here. This is 2.5, so this is going to be 2.6, 2.7. And over here, this is going to be minus 0.5, so minus 0.6, minus 0.7, minus 0.8. So our answers are that x equals minus 0.8 and x equals 2.7. And we get 1 mark for each of those. So you get the marks if you're anywhere between minus 0.65 and minus 0.8, and 2.65 and 2.8. So you've got a little bit of leeway, so you don't need to worry too much. Here is a right angle triangle. The shape below is made up from 2 of these triangles, and our task is to work out the perimeter of the shaded shape, giving our answer to 3 significant figures. So what I can see here is I've got a right angle triangle and I know 2 of the sides. This means I can use Pythagoras' theorem to work out the missing side. So Pythagoras' theorem says that a squared plus b squared equals c squared, where c is always the hypotenuse, so that's going to be this side here. And then a and b can be either of the other ones, so I'm going to say this one's a and this one's b. So using this, we're going to have 10 squared, because a is equal to 10, plus 8 squared, because b is equal to 8, equals c squared. So working this out in the calculator, we're going to get that c squared equals 164. To get c, we're going to square root both sides, and that's going to give us plus or minus the square root of 164, which is going to be plus or minus 2 the square root of 41. Now you might notice we've got 2 solutions. We've got plus 2 root 41 and minus 2 root 41. However, we can ignore the negative since we can't have negative length, because we said at the start that c is going to be this length here, which means our final answer is that c is 2 square root of 41. Now we're told that the shaded shape below is made of 2 of these triangles. Now these triangles are identical to the one above, so we can fill in the missing lengths. So this shorter length here, this is the base of our right angle triangle, and we know that that's 10 millimeters. Now we just worked out the hypotenuse, that is going to be 2 root 41. Now this is our other triangle here. So this whole thing, not just the small part, this whole length here is going to be the hypotenuse. So that's also 2 root 41. So this part here is going to be the length of this whole thing here. So 2 root 41. And we're going to subtract this part here. So 10 millimeters. So this yellow bit here is 10 millimeters and this green bit is 2 root 41 minus 10 millimeters. So now we've got enough to work out the perimeter. The perimeter is going to be 10 plus 8 plus 8 plus 2 root 41 plus 2 root 41 minus 10. We get 41.61249 ... and you'll have even more numbers on your calculator. However, we want that to 3 significant figures. So the answer is going to be 41.6. 3 significant figures. We get our first mark for realising we need to use Pythagoras and getting the value of c squared. We got our second mark for then getting the value of c. We got our fourth mark down here for working out the perimeter. And the fifth and final mark if we get it correct to 3 significant figures. ABC is a right angle triangle. And in part A we need to work out the length of BC, giving our answer correct to 1 decimal place. So we're trying to work out this length here. So to do this we can use trigonometry. So we got this little helpful reminder here, SOHCAHTOA. I'm going to use that in a second. Now the first thing I need to do is label the sides. So we've got a right angle triangle, and we've also got one known angle. Whichever side is connected to the right angle and the angle we know, we can label as the adjacent side. The side that's opposite the angle that we know is the opposite side, so we're going to label it as an O. And the side that's opposite the right angle is the hypotenuse, so we're going to label that H. Now this side here is the one I want to work out. So we're going to look at SOHCAHTOA here and see what we can do to work out this length that we want to find out. So we know it's got to include an O, so we can ignore this part here. So it's either going to be sine or tan. So we need to look about what we have information about. We have information about the adjacent, but not the hypotenuse. So we can't go with sine because that would have two unknowns, the opposite and the hypotenuse. So we're going to have to go for tan. And what this essentially means is we've got tan of some angle is going to equal the opposite over the adjacent. So in our case, we got tan of 56 degrees equals opposite, because we don't know that yet, over adjacent, which is 12. Well, what is the opposite side? That is the length that we want to work out, BC. Now, if I multiply both sides by 12, I'm going to have 12 tan of 56 degrees equals the length BC. So if I put all of this into the calculator, I'm going to get that BC equals 17.79073 ... But we want that to one decimal place, so that's going to be 17.8. So the final answer here is 17.8. So we get 1 mark for our working over here, and 1 mark for the correct final answer to one decimal place. Now for part B, we're told that PQR is a right angled triangle. And we need to work out the size of the angle marked X, giving your answer correct to one decimal place. So again, we're going to use trigonometry. And again, we can use SOHCAHTOA to help us. But this time, instead of working out the length of side, we're working out the size of an angle. So again, step 1 is to label A, O and H. So the one that's connected to the angle and the right angle is the adjacent side, so A. The side that's opposite the angle is opposite. And the last one here is the hypotenuse. So what information do we know? Well, we've got some information for the adjacent and for the hypotenuse. So this means we have to use cos, because that uses our information for the adjacent and hypotenuse. So what this means is that cos of some angle is the adjacent over the hypotenuse. So in our case, we're going to have cos of our angle x. And it's going to equal the adjacent over hypotenuse, so 15 over 18. Now to get this x by itself, we can do inverse cos. So we say x equals inverse cos of 15 over 18. And if we put this into the calculator, we get 33.5573 ... However, again, we want one decimal place, so that's going to be 33.6 degrees to one decimal place. So the final answer is 33.6 degrees. And again, we're going to get 1 mark here for working, and 1 mark for the correct final answer to one decimal place.
The group frequency table gives information about the time in minutes taken by 50 people to solve a puzzle. So here we've got the group frequency table, and Brian was asked to draw a cumulative frequency table for this information. So this is the table that Brian drew when he was asked to draw a cumulative frequency table. And the question goes on to say, write down one thing that is wrong with this cumulative frequency table. So firstly, let's have a look here at the frequency part. So we've got our frequencies here, so 5, 8, 12, 15, 7 and 3. And here Brian's drawn cumulative frequency. And it looks like he's got this correct because we start with 5 and then we've got 13, which is correct because we've got 5 and we're adding on the 8 here because it's cumulative, giving us the 13. And then 25, so we've got the 13 from the 5 and the 8 plus the 12, giving us 25, and so on and so on. So you can check all those and see that Brian's got the cumulative frequency correct. However, what he's got wrong is this column here. For example, taking the 13 here, Brian's saying that the 13 has come from between 10 and 20. But it hasn't, because the whole point is it's cumulative. This 13 has come from this 5 and this 8, which is between 0 and 20. So not just between 10 and 20, because between 10 and 20 it's only 8, but between 0 and 20 is 13. The same way when we get down to this 50 here, that's everything. So it's not just between 50 and 60, it's going to be between 0 and 60. So this here is what Brian should have done. So writing down one thing that is wrong with the cumulative frequency table, so there's an error in the inequalities. They should all start going from 0 like this. And I'm just going to give an example to make it clear. So I'm going to say, for example, we should have t is greater than 0 and less than or equal to 20, instead of greater than 10 and less than or equal to 20. And for an answer along those sort of lines, you get 1 mark. Liquid A has density of 1.8 grams per centimetres cubed. Liquid B has density of 1.2 grams per centimetres cubed. 80 centimetres cubed of liquid A is mixed with 40 centimetres cubed of liquid B to make 120 centimetres cubed of liquid C. So we need to work out the density of liquid C. So to start off, we need to know this formula here. We've got density is mass divided by volume. So focusing in on liquid A first, And we're told liquid A has got a density of 1.8 grams per centimetres cubed. And we're not sure what the mass is yet, so I'm going to say mass of A. And we're told to make up liquid C, we need 80 centimetres cubed as the volume. So now we can solve this to work out what the mass of liquid A is. Now if we multiply both sides of the equation by 80, on this side the 80 will cancel with the bottom here, and then we're going to have 1.8 multiplied by 80. So it gives us that the mass of A equals 80 multiplied by 1.8. So it's going to be 144 grams. Now we're going to do the exact same for liquid B. So we're told that liquid B has a density of 1.2 grams per centimetres cubed. So popping it into our formula, we're going to have 1.2 equals, and then again the mass is the unknown part. It's going to do mass of B, and that's divided by the volume. So again, to make up liquid C, we need 40 centimetres cubed of liquid B. So we're going to put 40 there. In the same way, if we multiply both sides by 40, we're going to have that the mass of B equals 1.2 multiplied by 40, giving 48 grams. Great, so what we've got here is we've got making up liquid C. When we combine these amounts of liquid A and liquid B, it gives us liquid C. So essentially, to work out the density of liquid C, we need to add what we worked out for liquid A and liquid B that's part of liquid C. Okay, so we want to work out the density. And the mass, well, that's going to equal the liquid A mass plus the liquid B mass. It's going to be 144 plus 48. This is going to be the liquid A volume plus the liquid B volume. So it gives us 80 plus 40. So if we tidy that up a bit, we're going to have 144 plus 48, giving 192. And divided by 80 plus 40, which is 120. And that's great because we know in the question that liquid C has a volume of 120 centimetres cubed. So last, if we put this in the calculator, we'll have 192 divided by 120, giving 1.6 grams per centimetres cubed. So 1.6 right here is the final answer. So we get a 1 mark up here for our working, so for looking at liquid A and liquid B as part of liquid C. We get another mark for our working here, work out the density of liquid C. And third and final mark if we get the correct answer of 1.6. The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. And in part A, we need to work out the interquartile range of the information in the box plot. So this line here on the box plot represents the upper quartile, and this line here on the box plot represents the lower quartile. So if we want to work out the interquartile range, which I'm just going to say IQR, we need to hit the upper quartile. So upper quartile, I'm going to subtract the lower quartile. So for our case, we're going to have the interquartile range. And let's see what upper quartile we've got. So we just quickly need to work out the scale of our diagram here so we can work out what measurements the lines represent. So I'm going to take this as an example. We're going from 80 to 120. Halfway between 80 and 120 is this line here, because you can see it's slightly more bolded. And halfway between that, we're going to have 100. So now let's look at this range. We're going from 80 to 100. And how many little boxes do we have? Well, we've got 1, 2, 3, 4, 5. So going between 80 and 100, the amount, the difference is 20. So that covers 5 boxes. So the range of 20 is covered by the 5 little boxes. So one box represents, so I'm going to do 20, which is the total, divided by 5, which equals 4. So every time we move along one little box, we're moving along 4. And that should help us when we work out the lower quartile and the upper quartile. So we're going from 160 here up to 200 here. So here must be 180. And each of these little boxes represents 4. So this line here is 2 along from 180. So we've got 184, 188. The upper quartile is at 188. Now let's do the same for the lower quartile. So starting at 40, the boxes again we're going to represent 4. So we're going to go to 44, 48. And then this line here for the lower quartile is halfway within this little box here. So we're at 48 here, but instead of going all the way 4 more to the next box, we're only going to go 2, so halfway. So from 48, 50. So the interquartile range, we're going to have the upper quartile, so 188, subtracting the lower quartile of 50, giving an interquartile range of 138. So the answer is 138 minutes. So we get 1 mark here for either working out the upper quartile or the lower quartile. Then we get a second mark for working out the interquartile range itself, so getting 138. Now for part B, Becky says that 50% of people waited at least 2 hours. And is Becky correct? We need to explain why. Well, again, we're going to take a look at our box plot. And we need to see where the median is. So the median is represented by this line here. And that's at the 120 minutes mark. So the median is 120 minutes, or if you say that in hours, that's 2 hours. So this means that 50% of the people waited more than 2 hours, and 50% of the people waited less than 2 hours. If we look at the statement, Becky said that 50% of the people waited at least 2 hours. So yeah, Becky's correct, because the median is at 2 hours. So that means that 50% of the people waited 2 hours or more. Because look at the box plot, we can see from the median at 2 hours or 120 minutes. And it spans all the way up to the highest value at 200. So 50% of the people are within that range there. So it follows that Becky's correct. They waited for at least 2 hours. And if we get a statement, something like that, we get 1 mark. The table gives us information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. Becky was asked to compare the distribution of lengths of times people waited on Monday with the distribution of lengths of times people waited on Tuesday. She wrote people had to wait longer on Tuesday than on Monday, and give one reason why Becky might be wrong. So now when we looked at the box plot before, which is their data for Monday in the hospital, we can see that the longest time was at 200. So we can see here on Tuesday, the longest time is actually higher than that, 210. So on the face of it, it might look like on Tuesday people had to wait longer. However, that could be one anomaly. That could be one time that this person had to wait to 210. And the rest of the time, everyone had to wait a really short amount of time. So we need to look at the distribution as a whole. A good thing to check is the median. So now looking back from our previous part on the box plot, we know that the median for Monday, so in part A, is 120. However, here the median for Tuesday is lower. It's only 100. So we can't be for sure, but that's a good indication that Becky may be wrong. And the wait times could have been less on Tuesday than Monday. So I've written as my answer, the median is lower on Tuesday, so 100 compared to Monday, 120, which suggests that Becky could be wrong. For a statement, something along those lines, giving a reason, we get 1 mark. Louise invests X pounds in better investments for 3 years. Sadiq invests X pounds in County Bank for 3 years. So at the end of the 3 years, the value of Louise's investment is £344,605. So using this information, we need to work out the value of Sadiq's investment at the end of the 3 years. Okay, so Louise invested with better investments. So these were her terms. She invested X pounds to start off with. So now the interest each year is 2.5%. So the amount of money, we want to go up by 2.5%. So increasing by 2.5% is the same as multiplying by 1.025. So if here I put, we're going to multiply by 1.025. So this is after 1 year. So we start with our original amount. And in 1 year, it's going to go up by 2.5% because per annum means each year. So 2.5% per year. So multiplying by 1.025, we get our result after 1 year. However, we're looking at the end of 3 years. And how compound interest works is that whatever we have after the first year, including the original amount and the interest, we then get 2.5% the next year on all of that. And then in the third year, we're going to get all of that money and we're going to multiply it by 1.025 again to get the result. So this is the result after the first year. So we got our original money and the interest, and we want to get 2.5% on top of all of that money. So I'm going to multiply again by 1.025. So this is the result after 2 years. If we multiply again by 1.025, that's the result after 3 years. And now we're told that Louise's investment after 3 years is £344,605. So we know that this number will equal 344,605. So now if we tidy this up a bit, essentially we've got 1.025 multiplied by itself, multiplied by itself. So a nicer way we can write that is we can write 1.025 to the power of 3. And then that's multiplied by x equals 344,605. So now we can solve this to work out the value of x. So if I divide both sides by 1.025 to the power of 3, this and this cancel, leaving us with x by itself on the left-hand side. And if we put all of this on the right-hand side in the calculator, we get an answer of 320,000. So therefore we know Louise's initial investment amount was 320,000. However, we can see because Louise invested that, but also we know Sadiq also invested that. So Sadiq's initial investment must also be 320,000. So now different to Louise, Sadiq invested it with County Bank. So again, it's compound interest, so it works in the same way. But it was 2% per annum, so per year for 2 years, and then 3.5% per year after that. So Sadiq had 320,000 to start with. And then for the first 2 years, we're going to multiply by 1.02. And we're doing that for 2 years, so we're going to do that again. And then for the third year, it goes up to 3.5%. So that's going to be multiplying by 1.035. And as before, we're multiplying here by 1.025 because we're increasing by 2.5%. So here it's 1.02 because we're increasing by 2%. And 1.035 because we're increasing by 3.5%. So if we pop this into the calculator to work it out, I get a value of 344,580 and 48p, which is our final answer. We get 1 mark up here for starting the process of working out what the initial investment amount was. We get a 2nd mark here for working out what the initial investment amount was. Then we get 1 mark for working down here, and a final mark if we get the correct answer. Here is a sketch of line L. The point P is at -6, 0, and the point Q is at 0, 3, and both the points lie on the line L. The point R is such that PQR, so going from point P up to R, is a straight line, and going from P to Q, and then going from Q to R, the distance is of the ratio 2 to 3. And using this information, we want to find out the coordinates of R. So firstly, I'm going to have a look at the x coordinates. So we're going to go from -6 for P to 0 for Q, and then from 0 on Q to something we're not sure about yet for R. And the ratio here is 2 to 3. So we're going from -6 to 0. So if I do 0 minus -6, it's going to equal 6. So we're in the ratio 2 to 3. We can see here for the x coordinate, P to Q is going to be 6. So we're in the ratio 6 to something. To get from 2 to 6, what do we do? Well, we multiply by 3. So if we do that to the other side here, we're going to get 9. So the distance from Q to R in the x direction is 9. Now let's do the exact same for the y coordinates. So the distance between P and Q, we're going from on P, it's on the x-axis, so it's 0. And at Q, it's got a y value of 3. So we're going to have 3 minus 0, which equals 3. And again, we've got our ratio of 2 to 3. Now we know for P to Q, it's 3. So how do we get from 2 to 3? We're going to multiply by 3 over 2. So if we do the same to the other side as well, if we multiply by 3 over 2, we get 9 over 2. We're almost there. So look at R. We want to know its position on the x-axis and its position on the y-axis. Well, we know that going from Q to R, like this, is a distance of 9. Well, that's the same as going from the origin to R. So the position of R on the x-axis is 9. So we can put in here an x value of 9. Now we know here, going from Q up to R, that's a value of 9 over 2. However, the y coordinate of R isn't 9 over 2. So we can see here, we've still got this bit from the origin. So this distance here is 3. So the distance here of R to the origin in the y direction is going to be 9 over 2 plus 3. So 15 over 2. And then that's our final answer. We can put that as the y coordinate of R. So we get 1 mark for all of this working out here, and a 2nd mark if we get the x coordinate and the y coordinate correct. Now part B says we need to find an equation of the line that is perpendicular to L and passes through Q. Now the first thing I'm going to do is I'm going to find an equation for the line L. So to do that, we need 2 points that go through the line. So I've got Q and P. And let's work out the gradient. So from these 2 points, the gradient, so M, and we work that out by doing the change in Y divided by the change in X. So if we do the change in Y, so I'm going to do the Y of Q minus the Y of P, so 3 minus 0, over the change in X, and we need to keep it the same way around. So I'm going to do the X of Q minus the X of P, so 0 minus 6, that's going to give us 3 over 6. So this is the gradient of the line L. So now we want to find the equation of the line that is perpendicular to L. So to get the gradient of the perpendicular line, we need to take the negative reciprocal of the gradient. So doing that, we flip the numerator and denominator. So we're going to get 6 over 3, and we make it negative. So this here is the gradient of the line perpendicular to L. So now let's work out the equation of the whole line itself. So the equation of a line is y minus y1 equals m multiplied by x minus x1. And we're told that our line should pass through the point Q. Well, we know what the coordinates of Q are. So we've got all we need. So we've got y minus y1, so minus the y value of Q, which is 3, equals m, So we work that out as minus 6 over 3 multiplied by x minus x1, so the x value of q, minus 0. And let's tidy that up. So we're going to have y minus 3 equals, well, minus 6 divided by 3 is minus 2. And x minus 0 is just x, so minus 2x. And tidy that up again. We're going to add 3 to both sides. We're going to get y is minus 2x plus 3. And that is the final answer. The equation is y equals minus 2x plus 3. So we get our first mark for finding the gradient of L. Then we get another mark for finding the gradient of the perpendicular line, so taking the negative reciprocal. Then we get a third and final mark for the correct equation of a line. Expand and simplify x minus 2 multiplied by 3x plus 2 multiplied by 2x plus 3. Whenever I have a question where I need to multiply out 3 brackets like this, what I always do is I pick 2 of the brackets and multiply them out and then multiply by the third bracket. So we can pick any combination of these 3 brackets to be the first pair we go for, but just for simplicity I'm going to pick the first 2. So we need to multiply every element in one bracket with every element in the other bracket. So I'm going to start with the front element, so I'm going to multiply x by 3x, giving us 3x squared. I'm now going to multiply the outside element, so I'm going to do x multiplied by 2, giving us 2x. Now next I'm going to do the inside elements, so I'm going to do minus 2 multiplied by 3x, giving minus 6x. And last but not least, if we do minus 2 multiplied by 2, we get minus 4. So tidying this up a bit, we're going to have 3x squared. But we can see here we've got a 2x and a minus 6x. So they're both in terms of a single x. So we can collect the terms together. So 2x minus 6x gives us minus 4x. And we're still going to have our minus 4 constant there on the end. So now we're going to take that and put it in a bracket itself. So we're going to say 3x squared minus 4x minus 4. And then we're going to bring down our remaining bracket. So again, we're going to do the same thing. We're going to multiply every term in one bracket with every term in the other bracket. So let's go 3x squared multiplied by 2x gives 6x cubed. Now I'm going to do 3x squared multiplied by 3, giving us 9x squared. Now I'm going to do minus 4x multiplied by 2x, giving us minus 8x squared. Minus 4x multiplied by 3, giving minus 12x. Minus 4 multiplied by 2x, giving minus 8x. And minus 4 multiplied by 3, giving minus 12. So now we're going to tidy up and collect like terms like we did last time. So I can see I've only got a single x cubed term, so I can keep that the same. Now I can see I've got an x squared here and an x squared here, so we can combine them. So 9x squared minus 8x squared gives us 1x squared. Now again, I can collect these x terms together. So minus 12x minus 8x gives us minus 20x. And last but not least, we've just got a single constant on the end. So it's going to stay the same, minus 12. So that right there is our final answer. We've expanded the brackets and we've simplified it down by collecting like terms, leaving us with this expression here. So we got our first mark here for multiplying out 2 of the brackets. We then got our second mark here by attempting to multiply by the third remaining bracket. And the third mark, if we do that correctly, and get the right answer. In a school, there are 16 teachers and 220 students. Of these students, 120 are girls and 100 are boys. One teacher, one girl and one boy are going to be chosen to represent the school. And we need to work out the number of different ways there are to choose one teacher, one girl and one boy. So how many ways are there to choose one teacher? Well, there are 16 because there are 16 teachers. Now, how many ways are there to choose one girl? Well, there are 120 because there are 120 girls. So we've got 16 ways to choose a teacher and then 120 ways to choose a girl. So we're going to multiply by 120. So 16 ways to choose a teacher by 120 girls. And how many ways to choose one boy? Well, 100 because there are 100 boys. So again, we're going to multiply by 100. And if we work that out, that gives us an answer of 192,000. So we get the first mark for our working here. So doing 16 multiplied by 120 multiplied by 100. And the second mark for the correct answer. A, B, C and D are 4 points in a circle. SBT is a straight line and it's a tangent to the circle. An angle ABD is 20 degrees. And we're told that the size of angle BAD and the size of angle BCD are in the ratio 3:1. We need to find the angle SBA, giving a reason for each stage of our working. The size of the angle BAD and the size of the angle BCD is in the ratio 3:1. So that's this angle here
and this angle here. Because that's really helpful, because if we look at the shape as a whole, well, you've got a quadrilateral here. And that quadrilateral is within the circle. So that means what we got is a cyclic quadrilateral. And one fact is the opposite angles in a cyclic quadrilateral add to 180 degrees. So this angle here and this angle here add to 180. Okay, so we've got 180 degrees in total, and we're sharing that in the ratio 3:1. So to do that, we're going to do 180 divided by, and there are 4 parts in total, so we've got 3 and 1, so add them together we get 4. 180 divided by 4, which is 45 degrees. So that's one part of the ratio. So from that, we can work out that actual size of the angles. So angle BAD is going to equal, so in the ratio there, we're looking at the 3 here. So it's going to be 3 multiplied by what we worked out for one part, which is 45 degrees, giving 135 degrees. Now let's do the same for the other angle, so BCD. So in the ratio, that's 1. So 1 multiplied by 45, giving us 45 degrees. And let's check to make sure these add up to 180, and they do. So this angle here, 135 degrees, and this angle here, 45 degrees. So now we've got more information to work with. We can work out this angle here. We know that angles in a triangle add to 180 degrees. So if we do 180 minus the 2 angles we already know, so 20 and 135, we get 25 degrees. So that means here, this angle is going to be 25 degrees. So now for the next part, I'm going to use the alternate segment theorem, which says the angle between a tangent and a chord is equal to the angle in the alternate segment. Now that's a bit confusing, so we're going to see how it applies here. I've got this triangle here, and we've also got a tangent. Now by the theorem, this angle, so going from the tangent to the triangle, is the same as the alternate angle. So down here, this one we worked out 45 degrees. So that angle there is 45 degrees because of the alternate segment theorem. Now I should probably make it clearer here that this 45 degrees refers to the whole of this angle here. But what I want to work out is the angle SBA. So just this bit of angle here. So this green bit is my goal. Now we've just worked out that the whole thing here is 45 degrees. And we know this bit is 20 degrees. So this green bit must be the difference. So for that we do 45 degrees. And we take away 20 degrees, leaving us with 25 degrees, which is the green bit there. So we get 1 mark for this bit of working down here and making sure we've given our reason. And we didn't actually need to do this step here, but if you did do it, you would get a mark for that. Or alternatively, we get 2 marks up here for getting the 45 degrees and giving a reason. We get a 4th mark up here for the correct answer of 25. Here is triangle ABC, and in part A we need to find the length of BC, giving our answer correct 3 significant figures. So our goal is to find this length here. Now for this, we're going to use the cosine rule, which says that a squared equals b squared plus c squared minus 2bc cos a. That's all well and good, but what does the a, b and c mean? Well, the capital A means the angle. So this capital A represents the angle of 72 degrees. And we've also got capital B here, which will represent this angle, capital C representing this angle. And then we look opposite to get the little letter. So this side, the side C to B, is the little letter A. This side opposite B, so of 8 centimetres from A to C, is little b, and so on. This is going to be little c. So our goal essentially is to work out the value of little a. So using the cosine rule, we've got a squared, well we don't know what a is, so we're going to leave it like that, equals b squared, well we know b is 8, so it's going to be 8 squared, plus c squared, we know that's 11, so 11 squared, minus 2, again b, so 8, c, 11, and multiply by cos a. So we've got cos of 72 degrees. Now we're going to work this out in our calculator. So popping this all in, it should say on your calculator 130.61 and then ... There's loads more decimal points after that. Now we've currently got a squared, but we want a value for a. So a is going to equal the square root of 130.61 ... Now if we keep the big long number with all the decimal points stored in our calculator using the answer button, we can do square root of answer, so square root of 130.61 ... giving us 11.4286 ... And we want 3 significant figures, so that's going to be 11.4. 3 significant figures. So we get 1 mark here for starting to use the cosine rule, 1 mark for working out the value of a squared, and 1 mark for the correct answer of a to 3 significant figures. Now part B says find the area of triangle ABC, and again giving our answer to 3 significant figures. So the area of a triangle equals half multiplied by A, multiplied by B, multiplied by sine C. Again, where A, B and C mean the same things as they did in the first part. However, this here is saying we need the angle big C. However, we don't have that, we've only got big A. So what we can do is we can shuffle around some of the letters. So we can do half multiplied by little c, little b, sine A. Now this means the exact same thing. We've got a sine of an angle, and then we've got the other two sides here. So essentially all we've done is relabel the angles and sides. So now we're able to do this. So it's going to be half multiplied by 11, multiplied by 8, because that's our values of c and b. Then we're going to multiply by sine of A, which is 72 degrees. And popping that all into the calculator, we get a value of 41.846 ... But again, we want three significant figures, so that's going to be 41.8 centimeters squared to three significant figures. We get 1 mark for working and 1 mark if we get the correct answer. Part A says you use the iteration formula x n plus 1 equals a cube root of 10 minus 2 multiplied by xn to find the values of x1, x2 and x3 starting with x0 equals 2. So what does this mean here? So here we're referring to xn. So this is our current value of x. And in order to get the next value of x, so x of n plus 1, we're going to do the cube root of 10 minus 2 over the current value of x. And that will give us the next value of x. So we're starting with the value x0 is 2. And we want to get x1. So we just need to follow what it tells us to do. So to get from x0 to x0 plus 1, so x1, we do the cube root of 10 minus 2 xn. So this is x of n plus 1. So n plus 1 is 1. So xn, that's going to be x0. So we're looking to our previous value of x. So we're multiplying by 2. So this is going to be the cube root of 10 minus 4. It's the cube root of 6. And let's put that on the calculator to give us 1.8171 ... And the numbers will carry on your calculator. Cool, so now we need to work out x2. So it follows the exact same pattern. We're going to have the cube root of 10 minus 2 multiplied by our previous value for x. So in this case, it's going to be x1. And that's going to be this value here. It's going to bring that down. We're going to have 1.8171 ... We're going to get 1.8533 ... And this is the really important point. In this calculation, we need to use the long number that we saw in our calculator. So you can store that in your calculator using the answer button, so the A and S button. And when you work x2 out, you can't round x1. You need to use the complete long number that you had stored in the calculator. Great, so now our last step is to get the value of x3. So it's the complete same process we've done so far. We need to do the cube root of 10 minus 2 of our previous value, so the value of x2 in this case, which is 1.8533 ... Remember, like we said, we need the whole long number with all the decimal points, so we can use the A and S button on our calculator to help us. And if we work that out, we will get 1.8462 ... And we get 1 mark for each correct value we get. Now for part B, the values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form x cubed plus ax plus b equals 0, where a and b are integers, and we need to find the value of a and the value of b. So from part A, we were told that x of n plus 1 is the cube root of 10 minus 2 x of n. So from that, I'm just going to say x is the cube root of 10 minus 2x. So essentially, we're just treating this as variable x and this as a variable x. Now I'm going to rearrange it. So if I cube both sides, we're going to have x cubed equals 10 minus 2x. If I add 2x to both sides and take away 10, we're going to have x cubed plus 2x minus 10 equals 0. And we're told in the question we're looking for something of the form x cubed plus ax plus b equals 0. And that's good because we got something of that form. We've got x cubed plus 2x plus minus 10 equals 0. So it's a bit easier to visualize it if we get rid of this and we add a plus here. So we're going to have plus minus 10 equals 0. It means the same thing, but it means we can easily match up a and b. So we can see from here that we've got ax and 2x, so that means a is 2, and plus b, and we've got plus minus 10, so b is minus 10. And getting both of those, we get our 1 mark. Some people took part in the first round of a competition. The histogram gives information about the scores of these people in the first round. So 20% of the people got a score high enough for them to qualify for the second round. And we need to work out an estimate for the score they need to qualify for the second round, showing all of our working. In a histogram, the area of the bars represent the frequency. Now all the bars are just rectangles. So to work out the area, we do the base multiplied by the height. So thus allows us to work out the frequency. So for this first one here, it's going to be 5 on the base, multiplied by, this is 0.5, 0.6, 0.7, 0.8. 5 multiplied by 0.8, giving a frequency of 4. Now for the next one, we've got 5, 10 along the base. And here we've got 1.5, so 1.6. So this one here is 10 multiplied by 1.6, giving 16. This one again, 5, 10. So 10 along the base multiplied by, we got 2, 2.1, 2.2, 2.2 multiplied by 10, giving a value of 22. And last but not least, we got 5, 10, 15 on the base here, going up to 1.1, 1.2. So 1.2 multiplied by 15, giving a frequency of 18. So this means that 18 people got a score between 25 and 40, 22 people got a score between 15 and 25, 16 people got a score between 5 and 15, and 4 people got a score between 0 and 5. So how many people were there in total? That's going to be 4 plus 16 plus 22 plus 18, giving a value of 60. So there are 60 people in total. Now we're told that 20% of them got a score high enough to qualify. So 20% of 60, if you do 60 multiplied by 0.2 is 12. So we know that the top 12 people qualified. So this top box has 18 people in it. So to qualify, you're going to need to be somewhere in this box and someone in the top of this box. However, we need to estimate the exact score within this box that you need to be passed to have qualified to be those 12 people. So to do this, I'm going to assume that these 18 people are evenly spread out within this box here. If I do 12 over 18, that equals 2 over 3. So that 12 is represented by 2/3 of this box. And that's quite nice because we've got 1, 2, 3 sections here. So this bit's the cutoff. We've got 2/3. So in total, the box is 18. However, this little bit here, so going down from this cutoff that we worked out, is going to be 12. And this bit here is going to be 6. So bringing that all together, this means that the qualifying score for the second round is 30. Because we're told that 20% of the people got a high enough score, 20% of the people is 12, and the top 12 people got a score of above 30. So that's our estimate for the score needed. So you get 1 mark up here for finding our frequencies, another mark for finding the total number of people, 1 mark here for realising that that means that 12 people qualified, and the fourth and final mark if we get the correct answer of 30. Here is a graph of y equals sine x for x between 0 and 360. And part A says we need to use this graph to find estimates for all 4 solutions of sine x equals 0.6 for x between 0 and 720. So we're going to ignore this bit for a second and just focus in on this. So sine x equals 0.6. So I'm going to find 0.6 on the y-axis. So this is 0.5. And working out the scale, we can see that one little square up from that is 0.1. So this is going to be 0.6. So I'm going to draw a line there at y equals 0.6. So now we've got our line. We're going to look for the points where this line intersects the graph of sine x. So that's at this point here and this point here. So if we take a closer look, that's going to be at this point here and this point here. And we're going between 0 and 90 here. So that means here we've got 30, here we've got 60. And we're going between 30 and 60 here, and we've got 1, 2, 3, 4, 5 squares. So that means each square is going up in 6. So that means at this point here, where we have the intersection, is going to be at x equals 36. And the same for the other point of intersection. The big squares are going up in 30. So we've got 90 plus 30 going to 120 here. So that makes here we've got 150. And this is one little square back from 150. So it's going to be 150 take away 6, giving us x equals 144. Great, so that's our first 2 solutions. We've got x equals 36 and we've got x equals 144. But we have a little clue in the question. It's saying all 4 solutions, so we know we're not done yet. We've got 2 more to get. We've currently found the 2 solutions between 0 and 360. However, we're going between 0 and 720. Now this is the graph for sine x, and it takes this shape. And what actually happens is it repeats. So going on from here, it's going to do the same shape carrying on. So let's imagine that this line at y is 0.6. It carries on forever as well. Where is it going to intersect? Well, between 0 and 360, we intersected at 36 and 144. And I said that our graph is essentially starting again from 360. So it's going to intersect 36 after 360 and 144 after 360. So essentially our graph of y equals sine x carries on. So our next two solutions are at x equals 360 plus 36, which equals 396, and x equals 360 plus 144, giving 504 degrees. So those are our final two solutions. And we get 2 marks if we get all of those. And because this question is reading off from a graph, we have a bit of leeway in our answer. So if in your answer you got a degree above or below these answers, that's okay as well. So now part B says the graph of y equals sine x is reflected in the x-axis, and we need to write down an equation of the reflected graph. And the answer here is y equals minus sine x. And this makes sense because when we're reflecting the x-axis, we're taking everything from y, so what y is equal to, and we're reflecting it, so times it by minus 1, to reflect it in the x-axis. So all these points will go down here. So since y equals to sine x, and to reflect in the x-axis, we need to take everything in y and multiply it by minus 1 to flip it over the x-axis. We've said our equation for the reflected graph is y equals minus everything that it was. So I can put brackets here, say we're timesing everything by minus 1. However, because we've only got a single term of sine x, we don't really include the brackets. And we write it like this. And if you get that, you get 1 mark. Now in part C, we're told that here we've got a graph of y equals f of x. And on the grid, we want to draw the graph of y equals f of x minus 2. So what this is saying is that we want to translate by vector to 0. And this top part of the column vector represents left-right movement, and the bottom part represents up-down. Well, the bottom part is 0, so we're not going to move up and down. And the top part is plus 2, which means we're going to move 2 to the right. So I'm going to first look at this point here. So if we move that 2 to the right, we're going to go 1, 2, and that's now going to go to here. Now this point, 1, 2, is going to be here. And if we keep doing this for other points, we'll start to see the shape form. So I'm going to go for this point here. So 1, 2, and then we're going to go here. 1, 2. If I do this one, we're going to go 1, 2, up here. And now I reckon I've got enough to draw the shape. So taking our ruler, we're going to join everything up. And if we draw everything in the right place like that, we get 1 mark. A, B, and C are 3 spheres. The volume of sphere A is 125 centimeters cubed. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of sphere B to the radius of sphere C is 1 to 2. And we need to work out the ratio of the surface area of sphere A to the surface area of sphere C. Okay, so firstly, we're going to be having a look at the ratio of sphere A to sphere B. Now we know the volume of sphere A and the volume of sphere B. So the ratio of the volume is going to be 125 to 27, because A is 125 centimeters cubed and B is 27 centimeters cubed. So now I'm going to have a look at length. Now a little trick to remember what to do here is we need to look at the units. So now the units for volume, well, that's been used in the question. We've got centimeters cubed. So sticking with centimeters, our units for length are going to be centimeters. So how do we get from here to here? Well, that's with the cube root. So that's what we're going to do. I'm going to take the cube root of 125 and the cube root of 127, giving me a ratio of 5 to 3. And in this case, when we're talking about the length, we're sort of thinking about the radius. So now we can look at the ratio B to C. So again, like I said, when we talk about the length, we can think of that like the radius in this case. So we're told in the question that the ratio of the radius of sphere B to the radius of sphere C is 1 to 2. So we can fill that in on our table. So now I've got 2 separate ratios. I've got A to B and B to C. But my goal is to look at the ratio A to C. So we need to get B to have a common value. How can I make B the same? Well, how do I get from 1 to 3? I'll multiply by 3. So to keep the ratio equivalent, we need to do the same to B here and C here. It's going to multiply the 1 by 3 and the 2 by 3, giving me the ratio of 3 to 6. So this is completely equivalent to this, because we've just multiplied everything by 3. And I can keep this the same. So I'm just going to bring down 5 and 3 here. So from this, what we can now do is look at our ratio from A to C. Because the B's here are the same value, we've now determined that the ratio of the length between sphere A and sphere C is 5 to 6. However, the question says we need to work out the ratio of the surface area of sphere A to the surface area of sphere C. So again, to do this, we're going to use our little trick. So the units for length that we're working with in this case is centimeters. So what does that mean the units for surface area are going to be? Well, the units for volume were centimeters cubed, But here we're talking about area, so it's going to be centimetres squared. Well, how do we get from centimetres to centimetres squared? We square it. So that's what we're going to do. I'm going to do 5 squared, and I'm going to do 6 squared, leaving me with a ratio of 25 to 36, which is our final answer. So you get 1 mark up here for finding the length ratio between A and B. You then get a second mark for getting a ratio between A and C. Then we get the final mark for getting down to the correct surface area ratio between A and C of 25 and 36. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there's a 70% chance that it will rain in the village on Monday, and we need to work out an estimate for the probability that it will rain in the village on Wednesday, showing all of our working. So I'm going to draw a little tree diagram to help us. So we're starting off at Monday, and this path is going to be the fact of it raining, and this is going to be the fact that it doesn't rain. And we're told there's a 70% chance that it will rain in the village on Monday. So as a decimal, that's going to be 0.7, which means there's going to be a 0.3% chance or 30% chance that it doesn't rain on Monday. Because the overall probability has to be 1, because it will either rain or not rain. Those are the only possibilities. So there's a 100% chance that it's going to rain or it's not going to rain. So 0.7 plus whatever the probability of not raining is has to equal 1. So we can work out that the probability of not raining is 0.3. Because now what I'm going to do is I'm going to write here a T for Tuesday. I'm going to let the tree branch off and see what happens. So focusing on this branch next, we're told if it rains on one day, the probability that it will rain on the next is 0.8. So it rained on Monday. On Tuesday, what's the probability that it's going to rain? Well, that's 0.8. And again, using the fact that we know that the probabilities have to equal 1, the probability of it not raining is going to be 0.2. Now, focusing in on this path here, the difference we got is that on Monday, it didn't rain. And we're told in the question, if it does not rain on one day, the probability that it will rain on the next is 0.6. So now this path, the probability of it raining on Tuesday is going to be 0.6. And not raining, again, using the fact that they add up to 1, is going to be 0.4. Now we've almost made it to Wednesday, so that's our goal. We want to work out an estimate for the probability that it will rain in the village on Wednesday. So it rained on Tuesday. The probability for rain, again in the question, if it rains on one day, the probability that it will rain in the next is 0.8. And again, no rain, because it rained on the Tuesday here. The probability of no rain is going to be 0.2. It didn't rain on Tuesday. And we know if it doesn't rain on one day, the probability that it will rain in the next is 0.6. So on Wednesday, probability of 0.6. And then no rain, 0.4. And for this branch, we've got Wednesday here. So again, because it rained on Tuesday, probability that it will rain on Wednesday is 0.8. And no rain is 0.2. And lastly, this path here, it didn't rain on Tuesday, so the probability of it raining on Wednesday is 0.6. And the probability of no rain is 0.4. We're working out an estimate for the probability that it will rain on the village on Wednesday. So which path down the tree would satisfy that condition? Well, okay, so if it rains on Monday, and it rains on Tuesday, and it rains on Wednesday, that would satisfy the condition of it raining on Wednesday. And when we talk about probability, when we see the word and, what we're going to do is we're going to multiply. When we see the word or, we're going to add. So what we had is rain on Monday and rain on Tuesday and rain on Wednesday. So 0.7 multiplied by 0.8 multiplied by 0.8, giving a value of 0.448. Now we could also have it raining on Monday and it not raining on Tuesday and then it raining on Wednesday. So 0.7 multiplied by 0.2 multiplied by 0.6, giving 0.084. So I'm going to look at the other path. Let's say that it didn't rain on Monday and then it rained on Tuesday and then it rained on Wednesday. That would satisfy the condition of it raining on Wednesday and would give us 0.3 multiplied by 0.6 multiplied by 0.8, giving 0.144. And last but not least, we could say that it didn't rain on Monday and it didn't rain on Tuesday either, and then it rained on Wednesday. So 0.3 multiplied by 0.4 multiplied by 0.6, giving 0.072. So now we've done all the paths we can go through the tree to meet the condition of it raining on Wednesday. So for it to rain on Wednesday, this could happen, or this could happen, or this could happen, or this could happen. I've said or, so we're going to add together. So to get the probability that it will rain on Wednesday, we've got 0.448 plus 0.084 plus 0.144 plus 0.072, which equals 0.748 is the final probability. So you get 2 marks for the working we did down here. 1 mark for then adding them all together. And then the fourth and final mark if you get the correct probability of 0.748. The time period, t seconds of a simple pendulum of length L centimetres is given by the formula here. Katie uses a simple pendulum in an experiment to find an estimate of the value of g. Here are her results. So she has L is 52.0, correct to 3 significant figures, and T is 1.45, again correct to 3 significant figures. We need to work out the upper bound and the lower bound of the value of g, and using pi to equal 3.142. So we're going to be working out the upper bound and lower bound of the value of g. So we want to know what g equals to. So I'm going to take this formula and I'm going to rearrange it so we get g equals something. So the first thing I'm going to do is I'm going to divide both sides by 2 pi. So the 2 pi here and here cancel, leaving us with t over 2 pi, and that equals the square root of L over g. Now we want to get rid of the square root here. So I'm going to square both sides. So for this side on the left, if we're squaring all of a fraction, that essentially means we're going to square the top of the fraction, so the numerator, and also square the bottom of the fraction, so the denominator. So on the left-hand side, we're going to have t squared over 2 pi all squared. That's going to equal L over g. So we square something that's square rooted, that gives us what's inside of the square root, so L over g. So now I'm going to multiply both sides by 2 pi all squared. So this leaves us with t squared by itself on the left-hand side, and then L multiplied by 2 pi squared over g. So now we're almost there. I'm going to multiply both sides by g. So that gives us g multiplied by t squared equals L 2 pi squared. Now lastly, let's divide both sides by t squared. The t squared here and the t squared here cancel, leaving us with g on the left-hand side, which is what we want, and L 2 pi squared over t squared on the right-hand side. So now this is what we want to work out the upper and lower bound of. Look at g, what's it made up of? We've got g equals, and what variables have we got? We've got L and t. So I need to work out the upper and lower bounds of t and L. So working with L first, we're told the value of L is 52.0, 3 significant figures. So if I do plus 0.1, we're going to have 52.1, and subtract 0.1 from L, we're going to have 51.9. So we're going to use this to help us. What's the upper and lower value we could have had for L, which means it rounds to 52.0 to 3 significant figures, while our lower bound is going to be halfway between here, so 51.95, and upper bound halfway between here. It's going to be 52.05. And you can test this out. Pick any number between 52.05 and 51.95 and round it to 3 significant figures, and you should get 52.0. Pick any number less than 51.95 or any number greater than 52.05 and round it to 3 significant figures, and you won't get 52.0. Now we're going to do the exact same for t. So we're going to add 0.1 and then go halfway between that again. So it's going to be 1.46, and halfway between that it's going to be 1.455. And if we subtract 0.1, we're going to have 1.44. And if we work out what's halfway between this and this, we are going to get 1.445. So here's our upper bound, here's our lower bound, and again we can test that, because any number within this range here, round to 3 significant figures, you'll get 1.45. Anything outside, it shouldn't round to 1.45. Now something you might have noticed is that with our upper bounds, if you actually take the value of our upper bound and round it to 3 significant figures, you won't get what we want. So if you take 1.455 and round it to 3 significant figures, you won't get 1.45. So if you take anything just below it, for example, 1.4549999, and then keep on going forever, and round this to 3 significant figures, you will get 1.45. However, it's not practical to write out an infinite amount of 9s. So by convention, we round that, and we'll take this value as the upper bound. You can see here I've got a less than sign to say, okay, let's not include this. However, for the bottom part, it's the lower bound, we've got a less than equal to sign saying, yes, let's include that. But I recommend practicing some simpler upper and lower bound questions so you really understand how it works. Great, so now we've got all we need to work out the upper and lower bound of the value of g. If I've got a big number, and I divide it by a small number, I'm going to get a big number. And now let's think, if I took a small number and I divide it by a big number, that's going to equal a small number. Okay, well, why is that relevant? We're working out the upper and lower bounds of g equals L multiplied by 2 pi squared over t squared. And it's like a fraction. We've got L on the top and t on the bottom. For the lower bound, we want a small number. So to get that, we want a small number divided by a big number. We've got L on the top and T on the bottom. So we want the smallest possible value for L on the top. So we're going to use the L lower bound. And we want the largest possible value for T on the bottom. So we're going to use the T upper bound. And we're going to take those values, sub it into our formula here to get the lower bound for G. So the lower bound for L is 51.95. And we're doing L multiplied by 2 pi squared. And remember, we're told to do pi as 3.142. And that's all squared. And we're dividing by T squared. And we said we're going to use the upper bound for T. So that's 1.455. And that's squared. And that gives us a value of 969.0181643. Now we're going to do the upper bound. And to get the upper bound, we want the biggest number possible. So it's a big number divided by a small number. So the way we get the biggest number on top is by using the L upper bound. And the way we can get the smallest number on the bottom is by using the T lower bound. So the value L for the upper bound is 52.05. And again, that's multiplied by 2 pi. So 2 multiplied by 3.142, all squared. And we're dividing that by T squared. The value we've chosen for T is the lower bound of T. So that's 1.445 squared. We get 984.3677853. And then we're done. We've got a value for our lower bound here and our upper bound here. So we get 1 mark here for working out the bounds of L and T. Another mark for rearranging to get G to be the subject. 1 mark down here for our working. And 1 mark if we get the correct value for the upper and lower bound.